All right, starting lesson 7.7, factoring special products. Okay, factoring the difference of two squares. All right, if you ever confront an expression with this structure, it simply factors into this: a plus b times a minus b. You could just as well write it as a minus b times a plus b. It's the same thing. All right, so if you look at this here, this is actually a difference of squares. We have the x squared, and then 25 you can rewrite as 5 squared. So since this is a difference of squares, I could rewrite it as a product as x minus 5 times x plus 5. Done. You have factored the difference of squares. All right, here I have 4z squared. 4 you could rewrite as 2 squared. Then you have z squared minus 1, and you could rewrite 1 as 1 squared. It's the same thing. So 2 squared z squared is the same thing as 2 times z, the whole quantity, squared, minus 1 squared. Now, since each term is squared, I could rewrite it as a product: 2z plus 1, 2z minus 1. And we have factored the difference of squares. All right, for example 2, just applying the difference of squares principle. All right, and then we have 102 times 6. All right, when we simplify it. So 6 times 102 is 612. Done. All right, here we're working with a quadratic of the form ax squared plus bx plus c. Okay, so I need to find two numbers that add up to 8 and multiply to give me 16. Those numbers would be 4 and 4. So I end up with n plus 4 times n plus 4. Since the factors are the same, I can condense the solution and rewrite it as n plus 4 squared. Done. For the next one, see, is there anything we could factor out here? No, we can't. So we're going to have to do big X with grouping. So I put negative 12 on top, and I put 4 times 9, 8 times c on the bottom, 36. So what are two numbers that add up to negative 12 and multiply to give me 36? Negative 6 and negative 6. So I take the first term, 4x squared, then I take the middle term, break it up using those two values. So negative 6x minus 6x. Then I have the last term, plus 9. Now I apply the grouping method. And from the first group, I factor out a 2x, leaving me with 2x minus 3. And out of the second group, I could factor out a negative 3, leaving me with 2x minus 3. All right, cool. I have a common factor in both terms now. So I pull out the 2x minus 3. And what am I left with? I'm left with 2x minus 3. All right, now notice that both factors are the same, so you could condense your answer into 2x minus 3 squared. Done. For example 4, solving a polynomial equation. Okay, we have a bunch of fractions here. This is a very simple method to get rid of all the fractions from the equation. You have to find the least common denominator. Okay, what is it? Well, for one denominator I have 3 here, for the other one I have 9. All right, so take the biggest denominator, find multiples of it that the other denominators go into. 3 goes into 9, so there's your least common denominator. So watch this. Multiply by 9 on both sides and watch the magic happen. All right, I'm going to distribute this 9. So I get 9x squared. Then I get 9 divided by 3 is 3 times 2 is 6. Then I have 9 divided by 9 is 1 times 1. That's just 1 and equals 0. Okay, now I'm going to solve. So I need to find two numbers that add up to 6 and multiply to give me 9 times 1, which is 9. So that would be 3 and 3. So I break up the second term using these two values. And I have plus 1. Now I group. From the first group, I factor out a 3x, leaving me with 3x plus 1. And out of the second group, I factor out a 1, leaving me with 3x plus 1. All right, the common factor in both terms is 3x plus 1, so I pull that out. And what's left over? 3x is left over, plus 1. All right, and the factors in my solution are the same, so I could condense the solution to 3x plus 1 squared. All right, that's all there is to it. Make sure to ask for help if you need it. Begin the assignment at the bottom of the page.